Hello everyone, welcome back to my YouTube channel Maths Beyond Basics. I am Ritu Bendre discussing on the topic of integration. In this video, we will be seeing the definition of integration and we will see how the formulas are obtained and we will also see the use of integration. To start with the use of integration, it's very simple. Here in integration, we will be finding the area under curve. So that's why we will use integration. Let's see what does this mean. To understand this, I am taking a simple example of a curve y is equals to 2x and now I am interested in finding the area under this curve. Okay, the shaded region is where I am interested in. The area of shaded region is where what I am interested in. So therefore, y is equals to 2x is the curve that I have considered, and if you see when you join this OB that is perpendicular to x axis, now you will see that this OAB is a triangle, is a right angle triangle. And particularly when we have a right angle triangle, the area is very easily obtained by using the formula. What does the formula for triangle says? That is the area of a triangle is half into base into height. So we will just put the values that we know. Half into the base is OB and the height is AB. The perpendicular height is AB. So see here, OB is nothing but an x and AB is nothing but y. And here the y is equals to 2x. So we will just substitute it. Half into x into 2x. That is this 2 and 2 get cancels. And x square is what the area of the curve under this shaded region is. Therefore the area is here equals to x square. Right. Now this was some example where we were finding the area under the curve. And the curve that the area was forming is very simple. That's triangle. That is very well known figure to us. And about this figure we know the area. But not every curve is such well defined. Not every curve is so well obtained, so well constructed that we know the formulas to find the area under that curve. For example, let me consider some random curve. Let us say this is y is equals to f of x. Now I am interested in finding the area under this curve. How do we find? This curve is unknown. This is some random function that doesn't have any good looking kind of figure whose area's formula is easily obtained, whose area's formula is known to us. For such functions, for such areas, we need integration. That's why the integration was introduced. Now let's see how the area under this particular y is equals to f of x is obtained. Now I am telling the general case, and this general case will be applied to all other functions that we will be seeing in coming session. Now let's just start with this. Now if you see, I will be considering one stripe. Let's say this is a stripe, that is the area under this curve. I am interested in finding the area under this curve. Now what I will do, I will cut this area in small stripes, very small stripes. I am cutting this area in very small stripes. Okay. Now what will happen if you observe, if I just join this, you will see that this is a rectangle. If you see, this is a rectangle, clear. And since it is a small stripe, this small stripe is named as dx. Dx means what? It is having very small length. It is having very small length. So I am naming it as dx. If this is dx, the length is called as y. The length is called as y. And if you observe, if I name this A, B, C and D. If you name this A, B, C and D, here A, B, C, D is nothing but a rectangle. Yes or no? It is nothing but a rectangle. So now, area of rectangle is given as length into breadth. So the length is dx and the breadth is y. Right? The breadth is y. Now, if I consider such stripes and if I join this and again I will obtain another rectangle and again I will be taking dx into y and again I will consider another stripe. I will do the same with all the stripes. Right? I will do the same with all the stripes. Then if I add all these rectangular areas, that way I am shading this region, then I will be finding the area of this particular portion. Clear? I will be finding the area of this particular portion. But if you see, there is some error, there is some area left out, there is some area that is not getting considered. Clear? And that error will be vanished when I am making this stripe very close. Right? If I make this stripe so thin that it is almost very close, these both lines are very close, then I will be finding the maximum area possible. Clear? See here, if this stripe is having some length, let's say dx, then the error was occurring. That is, some extra area was not getting considered. But if I make this same stripe very small, then the error is less. Then the error will become less. So if I make extra thin, then I will get less error. And this particular process is called as integration. That is, I cut this dx in very small thin stripes, and the y that I am interested in, the y under which the area is need to be found, I integrate it. And the integration nothing means what? It is adding up, it is summing up the small stripes area. That's what the integration is. That's how the integration was introduced. And here y is nothing but f of x dx. That's how the area under curve is found. Area under curve is found. So area under curve is given as integration of f of x dx. So next we will be seeing the formulas for integration. Okay. So now we have learned that integration is nothing but area under curve. Right. Now we will see how have the integration formulas been constructed. So there's one very famous saying for integration, that integration is an antiderivative, or the opposite of differentiation is integration. We will understand it how and why it is said. So basically in integration what we are doing, in all the formulas we are simply finding the area under that curve. Clear? So now we will see how the formulas are obtained. For example, the differentiation of the function x is 1. Right? Now what does integration mean? Integration is anti-differentiation. Now I will teach you why the integration of 1 dx is x. Why the integration of 1 dx is x. See, you just take the dx at that side and now simply integrate on both sides. So integration of dx, that is integration of 1 dx, here differentiation and integration get cancels and you will be getting x. Clear? And let us take another example. Let's say that d by dx of sin x is cos x. Now you will see why integration of cos x is always sin x. It is very simple. You just put your dx at that side, so you will get cos x dx. Now integrate on both sides. So after integrating you will get integration of d sin x, integration of cos x dx. Here differentiation and integration get cancels because they both are opposite to each other. So therefore integration of cos dx is nothing but sin x. So that's how we have obtained all the formulas. Now let's see why in every integration formula we will be adding plus c. That is, integration of dx is x plus c. Integration of cos x is sin x plus c. Why do we add this c? We will see it. In all the formulas, wherever we see integration, like integration of dx is basically written as x plus c. Now we are seeing why we will always add plus c. That is why we will be always adding constant of integration in all the formulas. So what was the formula for integration? How did we derive it? That is differentiation of x was equals to 1. Clear? And if you see the inverse process, that is dx is equals to, you would write dx and integrate on both sides, and that's how you used to get x is equals to integration of dx. So now if you see d by dx of x plus 1. What is d by dx of x plus 1? It is also equals to 1 only, right? It is also equals to 1 only. Why? Because d by dx of x is 1 and d by dx of 1 is 0, because differentiation of constant is 0. So if I write d by dx of x plus 1 is equals to 1. Now if you take the anti-differentiation, that is inverse process, d of x plus 1 is equals to integration of dx, and again here differentiation and integration will get cancels. Here you will get x plus 1 is equals to integration of dx. So if you see, integration of dx was x and integration of dx is also equals to x plus 1. And if you similarly do the same for, let us say, any constant k, you will again obtain the same, right? D by dx of x is 1 and d by dx of constant was 0. So therefore again if you take the anti-differentiation, you will get x plus k is equals to integration of dx, which is again x plus k is equals to integration of dx. Clear? So whenever we add constants and we differentiate it, it doesn't affect the final answer after differentiating, because eventually the differentiation of constant is 0. Here the constant doesn't affect the differentiation because the differentiation of constant is 0. So we will always include this constant in every case. plus c. Clear? And the same goes for all other. That is differentiation of sin x is equals to cos x. Differentiation of sin x plus 1 is also equals to cos x. Clear? So therefore, in general, we will write integration of cos x as sin x plus c, where c can be any real number, it can be any constant. And that's how we have obtained all the formulas for integration. So to integrate the formulas, to integrate any function, we should first know the definition and formulas for differentiation. So in this short video, we have learned the definition of integration, the use of integration, and how all the formulas have obtained. I hope this is clear to you. For more such content, like, share and subscribe. Thank you.